Hi there, this is a question from the 2017 Exam 2, and this is from the Matrix module. So this is question 1. If we have a look at the full question, we're only going to answer part II in this. But if we have a look at the full question, it's talking about a school canteen sells pies, rolls, and sandwiches, and the number of these items sold over the 3 weeks. So question A, in total, how many sandwiches are sold in the 3 weeks? We would be adding up the sandwiches. Part B of the question is asking what does the element M12 indicate? Have a look at the assessor's comments of how you need to word this answer. Moving onwards, part C is asking to solve what the price of one sandwich is, so having to solve A, B, and C using the simultaneous equation formula, manipulating that to the power of -1 to solve for that question. And which brings us to the part of the question that we're going to break down today. The matrix equation shown below shows that the total value of all rolls and sandwiches sold in the 3 weeks is $915.60, and it's been given by this matrix multiplication here and is showing an answer. Matrix L in the equation is of the order 1 times 3, so that means we've got 1 row and we've got 3 columns. So we're going to have 3 values in our standard matrix. So write down what the matrix L is. So when we are doing matrix multiplication, there's 2 types of matrix that we can use to add up values in columns and add up values in rows. So going to the notes, if we have a look here, if we want to sum our rows and columns, we can sum the rows by post multiplying by 1s. So what this would do is this would sum all these rows up. Or if we wanted to sum our columns, we can pre-multiply by a matrix of 1s. And in this question, they're actually telling us that it's a 1 by 3 matrix and it's pre this matrix. So what we need to do is look at this one here. So summing the columns by pre-multiplying by a matrix that has 1s in it. So an answer to this one could be very common to write the matrix answer as 1, 1, 1, but we need to identify that in this question, if we're going to add up these values, it doesn't actually equal $915.60. So 111 cannot be the answer, and I reckon this is what a lot of students would have got wrong in this question. So what we need to do is work out what these 3 values here are going to be to add up to 915. So if we added up $491.55 to 428, that does not equal $915.60, it equals $919.55. Go through the next one, $491.55, and if we add it to $487.60, once again, it doesn't equal this $915. The last option we have is the $428 added to the $487.60. That does equal $915. So what we need to do is have a matrix here that is not going to include this value, but is going to include this value and this value. So the easiest way is that we're going to pre-multiply by a 0, 1, 1 matrix, because when we do our matrix multiplication, from what we already know is we do our horizontal by our vertical. So this times this plus this times this plus this times this equals this. So that's why this first one in the matrix is a 0, because we don't need to include that. So a 0 times that equals 0. And then we go 1 times 428 plus 1 times 487 plus 0.60 equals that answer. Looking at the assessor's comments here, only 28% of the cohort managed to get this one correct, which is very, very, very low. I believe a lot of the students would have put a 111 to add this value up in the matrix. Hopefully this helps you identify how to use pre-multiplying of values and post-multiplying values to add up summing of rows and summing of columns, and this should be something in your bound resource in your exam.